Hey, hi everyone. In this video, we are going to create our first machine learning project using PyTorch. The name of the project is Thumb Calculator. So we are going to create a calculator which doesn't even know anything, but after completing this project, it will learn about addition using a very simple model. We are going to use PyTorch to create that model. And after completing this particular project, you will learn about what are tensors in PyTorch, what is a model, and basically we are going to use a linear model. So we will learn about what is a linear model, and we are also going to learn about how a particular model, a model is nothing but an algorithm, how it learns about the pattern of the data using gradients. So we are also going to understand what is a gradient. To create this project, you should have Python installed, and once Python is installed in your system, we are going to use Jupyter Notebook to create our project. So if you do not have Python and Jupyter Notebook installed, I have a link in the description and you can follow that link to install Python and Jupyter Notebook. But for now, I will tell you in short how can you install Jupyter Notebook. For that, you need to go to your terminal and you need to write a command pip3 install notebook. This will install Jupyter Notebook in your own Python environment. It might take some time like 10 to 15 seconds depending upon your internet connection, and after some time this will install Jupyter Notebook. It is already installed for me, so let me clear the console. And to create a project in Jupyter Notebook, we first need to run it. So to run a notebook or Jupyter Notebook, you need to run a command python 3-m space notebook. This will open a new notebook server or new Jupyter Notebook server, and this is the link to your server. So once you run the Jupyter Notebook command, it will automatically open a browser with this link localhost colon 8888 or wherever your Jupyter Notebook is hosted. First of all, we need to create a project. So you need to go to this new, click on Python 3, and once this is created, it will automatically open in a new tab. Let us rename our project Dumb Calculator, and this is our first project. So for one space Dumb Calculator. Now the first thing is we should have PyTorch installed as well to use PyTorch, right? So to install PyTorch, if it is already installed, then good. If it is not installed, you can go to your terminal and run a command pip install torch. This will install PyTorch in your Python environment as well. But if you want to directly install PyTorch using Jupyter Notebook, you can type this command, and in front of this command, you should have an exclamatory mark. Now this means that you want to run this command in your terminal. So once you type this code, run this code, and it will install PyTorch in your own Python environment. For me, it is already installed, so it is saying requirement already satisfied. So since it is already installed, I can remove this. Before we get started in our project, imagine we have a calculator, but it's a dumb calculator. It doesn't know how to add numbers. What is our goal? You remember our goal is to make our calculator add two numbers using machine learning. Well, this sounds dumb, right? I mean, we are creating a very small project, but this is how it starts. Everything starts with a small base you should have. And after completing this project, you will learn about a lot of concept of PyTorch and machine learning. To use PyTorch, we need to import the required modules. First is import torch. This is your main PyTorch library or the core PyTorch library. Second is import torch.nn as nn. This torch.nn means torch.neural network. This is a package which contains the neural network building blocks. And next is import torch.optim as optim. This particular package is used for optimization. There are optimization algorithm like SGD, which is stochastic gradient descent, or ADAM, or there are other algorithms as well. We are going to use those algorithms using this particular package. The next step is we should have a training data, right? We need to train our model. We need to train our calculator to understand what is addition. And once it gets trained on your data, it can do additions on any data which it has not seen earlier. So the training data is going to be x, which is equal to, so let us create a two-dimensional data. Now this is a two-dimensional list. In this we are going to write our data 1, 2 as a list, then 2, 3 as a list, and 3, 4. Let us give one more data 4, 5, right? Now this is a list. Now the first concept in PyTorch is a tensor. Every data we have in PyTorch should be like a tensor. Tensor is like an object which holds your data, but it is a PyTorch object and it can hold your data and perform various operations on it very efficiently. So to create a tensor, we should have some data like this, like a list, and now we need to pass this data in torch.tensor. This will create a new tensor for us. So x is now a tensor. We also need to specify the data type for our tensor. So after we give the data, give a comma and give your data type. So data type is equal to torch.float32. For now, let us keep it as float32. And one important thing to note here is every data in a tensor have just one data type. In Python list, we can have multiple data with multiple data types. But in PyTorch tensor, we should have the data in only one data type. all the data should belong to one data type. So we set the data type for our data as torch.float32. Now this is our input. What is our output? What's our output? Let me copy this x and replace this x and make it y. This is our output. And in case of 1 and 2, the output should be 3, right? In case of 2 and 3, it should be 5. In case of 3 and 4, it should be 7. And in case of 4 and 5, it should be 9. Now this is our training data. We have x as input, y as output. Make sure you run each block of code before moving to the next one. So this first block of code was about importing. To run this block of code, you can hit shift enter, or you can directly select the block of code and then hit this run button. This will also run your code. So once you click on it, if it is a star, it means that it is trying to process this code and trying to run it. But if it is a number, it means that your code is already executed. So now we have imported PyTorch packages, and now we also have our input data. The next is we are going to teach the model. So for that, we need to create a model, right? So let's do it. Let's create a class dump calculator. This dump calculator is going to be a model, and every model in PyTorch is created using this nn.module class. So whenever you are creating a new class, which is your machine learning model, it should extend this nn.module as well. This nn.module comes from this nn package, torch.nn neural network package. So now your dump calculator is also like a model. Now we need to implement the functionality. So def underscore underscore init underscore underscore. This is your constructor. It automatically gets called when you create the object of your model dump calculator. Inside this, you first need to initialize your model. And for initializing, you will have to call the super function, which means calling this nn.module class with your class or your model class dump calculator. And we also need to pass the self, which is your object reference, and then call the dot underscore underscore init function. Okay, now this function, now this will initialize your class as a model. Next is define the parameters which you need in your model. So we need to create a linear model, right? So let us create a linear model. Self.linear is equal to nn.linear. Now this linear is the linear regression. In linear regression, we try to create a relationship, a linear relationship from our input to our output. So you need to define two things. First is how much data will be there in your input. So our input has two data, right? 1 and 2. Because right now we are trying to add two numbers. So we have two inputs and one output, right? This is the shape of your data. Create a linear model with two input and one output. All right, so we have initialized our dump calculator. Dump calculator is our calculator or the model. Next, we need to implement the def forward method. This forward method will accept an input and make a guess or make a prediction based on your data. It will have this self, which is your object, and then x is your data. Inside this, we need to return the value which we want for our input x. For that, we can say return self.linear. So we are calling this linear variable, and this is nothing but our linear model. And inside this, we are going to pass our data x. Now our model is ready. This is a very simple linear model, and we are calling it as dump calculator. Let us create an instance of this model. So model is equal to dump calculator. Run your code and let's proceed further. The next is we need to have two variables. First is loss and second is optimizer. Now this loss will be equal to nn.mse loss. MSE loss means it's a mean squared error for regression, and it measures or counts how the prediction is from your actual value. So our model is going to predict something and it can produce some error. The loss is measuring what's the error. And what is this optimizer equal to? This is equal to optim. Now we are going to use this optim, the optimizer package, and optim.sgd, stochastic gradient descent. So we are going to use this optimizer, which is like an algorithm which improves your model based on gradients. So basically there is a term called as gradient, and this gradient tells you which direction should you move to improve your model's performance. And based on the loss, we try to understand what is our direction. So imagine there is a shooter who is trying to shoot on a target, and if he misses the target, maybe the bullet is going in the downward direction. So next time he will try to up his direction, right? So that is what the gradient is all about. The gradient will tell you where should you move or where should you improve to make your performance better. And we calculate it using the loss. Then this optimizer optimizes our model. So inside this, we need to pass our model parameters, model dot parameters, whatever parameters our model is using. And there is also something called as learning rate. This should be equal to 0.01 for now. This defines how fast or how slow you want your model to learn about something. So we defined it as 0.01. This is a rate. Now execute this code and let's move forward. Next is we need to teach our model, right? We need to teach our model based on this input data. But there is something called as epoch, right? This epoch means how many iterations or how many times do you want to teach your model. Again, the example of a shooter who is trying to shoot on a target. If he tries shooting one time, okay, good. If he tries it for two times, good. But if he tries it for 100 times, he will be great, right? So the more you learn, the better you are going to perform. So epoch is going to be 100. Let's try to teach our model for 100 times based on this data. We are going to feed this data 100 times, and after every learning, we are going to adjust the model's parameters so that it performs better. Now let's run a loop for e in range epoch, and inside this, first of all, we need to say optimizer dot 0 underscore grad. This line of code will clear all the previous gradients. It means that if you're trying to learn for 100 times, in every time when you learn, the gradient value is going to be neutral or 0. Okay, where we don't know we need to move up or we need to move down. It all depends upon how the output is going to be. So initially the gradients are going to be 0, and then let us create an output. So let us call it as output, and this should be equal to call the model with the value x. Now this x is a tensor and the shape is 4 by 2. 4 means the number of data we need to predict for, and 2 means the shape of each data. So the shape is 2, and you know our model is also expecting the shape as 2, right? That is 1, 2, 2, 3, 3, 4, and 4, 5. Now after you do this, it's basically predicting the values of these data. And initially the values which it predicts will be very random, completely random. So let's calculate what is the error here. So error is equal to, let's call this loss. The loss will calculate the error. So loss, inside this you need to pass your output. This is your actual output, and what are you expecting? We are expecting this data y. So let's pass it as y. Now this error will calculate the difference in the prediction and the actual values, and based on this we are going to have a back propagation. So we are going to say error based on whatever error we are getting dot backward. Now this backward function, what it will do is it will compute the gradients. Means where should you move now, up or down, and how much should you move up or down or right or left. You should adjust, the model should adjust its parameters. The error dot backward is basically doing a back propagation to compute the gradients. And once we have the gradients ready, the optimizer is going to update the gradients. So let's call it optimizer dot step. Step means update the model's weight, whatever weight or whatever parameter the model is having, update it. Once the update is done, next time our model is going to have a better prediction. Now since we are running our loop for 100 times, so let us calculate what is the error after every 10 turns. So let us write a logic. If e mod 10 is equal to 0, so let us print the error. So first of all, let us print the epoch number. So epoch is e, and in this particular epoch or in this particular iteration, the error or loss is error dot item. Error dot item will give you the actual error value. This is the error we computed, and this is the actual value we can see here. Now let us run this code and let us see what is how our model is doing right now. So run the code, and then you will see epoch 0. The value will be different for you, it is different for me, but the pattern will be almost similar. You can see that first time the initial prediction which it had, it is having the loss or error of 89.81, which is huge. But after every 10 turns, you will see the loss is decreasing, right? It's 0.11, then 0.10, 0.09, 0.08, and the loss or the error is decreasing after every epoch or after every iteration. So this is the training we gave to our model, and now our model is ready to predict our values. So let us actually predict the value. So let us create a test data. Test is equal to torch dot answer, and let us create two data. Okay, so we will have a two-dimensional data, two-dimensional list, and first data is 5, 6, and second data is going to be 10, 15, right? The data type should be torch dot float 32, the same data type, and then let us do the predictions. So now predict is equal to give our model this test data, and this time we don't want any gradients to be calculated. Okay, when you are actually performing your work, when you are actually doing the work in a production environment, or when your system is live, you don't need to compute the gradients. You know, the gradients means the direction in which you should move. You don't need to compute it, you just need to give the output of what you have learned so far. So if you don't want the gradients to be calculated, we need to write a line of code with torch dot no underscore grad. It means that no gradients are needed to be calculated during a testing. Now this is our final code. Also let us print this prediction. So print This is our predictions, and the predictions value is going to be this one, whatever we write inside this curly brace. So it will be predict dot, you can call a function numpy. Now this numpy function or numpy method is going to convert our output into numpy array. So let us do it. And now let us run the code. And now you will see the prediction is 10.5 and 22.9. Well, we were expecting around 11 and 25, but the prediction which we got, or the output which we got, is 10.5 and 22.9. Well, we know that this is not the best prediction it is having, but definitely now it is learning. Our dumb calculator is getting a bit smarter now. It is trying to learn how we can perform addition. Now what you can do is you can give it some more training data, and you can increase the number of epoch, right? You can increase the training, and after that, once you do the prediction, it will be much better than what we have right now. So let us actually do one thing. Let us increase the number of epoch. Let us give it 1000 more iterations or more training, 1000 times training. And this time we are only going to print the value of epoch or and the error after every 200 iterations. Okay, run the code, wait for some time, and this time you will notice that your loss, which is 0.05, is decreased to 0.01, 0.003, 0.0009, right? So the loss is decreased to a very small or minute level. So now let us try to do the prediction again, and this time you will notice we are much closer to our target. Okay, try to give some other data as well. Okay, keep this data and give one more data. 20 and 10 predicted. So we are expecting 30, we are getting 32.9. Well, we know that we are not doing that great, but we can see that the model is learning, right? Give it a training of 1000 more times, run this code again, and this time, and again do the predictions, and you will see that this time we have much better prediction: 10.9, 23.8, 33.1, right? So since we just have 4 training data, this is a pretty good model. If we have, instead of 4, if we have like 4000 training data, the predictions will be very close to the actual values. That's it for this project. The one task which I can give you guys is increase the number of training data, increase the number of epoch, that is the training, and then try to guess the values on different kind of input. Tell me in the comments that what are the output you are getting, or how close the output you are getting. And again guys, that's it for this project. You can find the code of this project in the description as a GitHub link. I have uploaded it in GitHub, and you can find the code from there as well. And if you find this video helpful for you, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well, because this is just the first project on PyTorch. We are going to have around 50 PyTorch projects, and we are going to go from the absolute beginner level, like what we did right now, to an advanced level as well. So if you are joining this community, joining this channel, you are definitely going to be an expert in PyTorch. So again, that's it. I will see you guys in the next video. Thank you for watching this video, guys.